లాస్ట్ ఇయర్ నుంచే మొదలైంది జాబ్.
Good evening, dear participant. So I'm audible. Sajna, madam, I'm audible.
Yes, sir.
Okay. Thank you, sir. So good evening, dear participants. So welcome to third day, 2-week faculty development program on impact of artificial intelligence in the field of agriculture. Speaker, sir, did you join, sir? Sir is not. So wait 1 minute. Hello, sir. Sir, please join, sir. Hello. Hello. Sir, please join, sir. Please join. Speaker, sir, joined, sir. Did you join, sir? Speaker, sir. Okay, sir. Okay, sir, join. So, thank you, sir. Speaker, sir, accepting our request. Now, I would like to request Manojna. Please read the profile of the speaker, today's speaker.
Yes, sir. Thank you. Dr. J. Somashekar received a PhD degree in computer science and engineering from JNTU-A, Andhra Pradesh in 2017 and an MTech degree from National Institute of Technology, Karnataka, NITK, Surathkal in 2010. He is currently working as a professor and HOD at the CSE department, Gopalan College of Engineering and Management, Bangalore. As a resource person, speaker, he has completed 110 AICTE FDPs, ISTE FDPs, STTPs, guest lectures, national and international webinars in 11 states of the country. He got All India rank of 43 in GATE, graduate aptitude test in engineering exam with a 98.4 percentile, and is also a exam trainer for GATE since 2011. He has 15 years of experience in teaching and 6 years of experience in research. He has published 23 research articles in leading journals, conference proceedings, and 2 international textbook chapters. He has 172 citations with a H index of 7 for his research publications. He is the reviewer for reputed international journals, SCOPUS, international conferences, and session chair for 3 international conferences and guest editor for 3 journals. He is also a visiting professor for a data science PG course at Government University, Kerala. Currently, he is guiding 2 PhD students at VTU. He also received the Innovative Collaborative Researcher Award in Medical Imaging for research collaboration with Dr. Qinghao Lai, Director ITRI, Taiwan, by WRC in association with United Medical Council. Also, he has received Best Outstanding Speaker Award, Best Paper Awards in conferences. He has conducted various FDPs, AICTE, STTPs, SDPs, national conferences, workshops, and national webinars as a convener and coordinator. His current research interests include image processing, machine learning, big data analytics, and ML for cybersecurity. Thank you so much, sir, for joining us today.
Thank you, Manojna.
Thank you, sir.
Sir, speaker, sir, please share your PPT, sir.
Sir, is it clear, sir? My voice is clear, sir, audible?
Yes, sir. Yes, sir. Audible, sir.
Okay. So thank you, sir. So are you able to see my full screen, sir?
Yes, sir. Yes, sir.
So good evening to all the participants. So thank you, madam, for nice introduction, and thanks to organizers for opportunity. So coming to the today's session for AICTU Training and Learning Atal FDP on impact of AI in the field of agriculture. So my topic is AI in agriculture and what are the applications and case studies and research directions. So I'm going to cover multidisciplinary concepts in today's session. and after end of the session, you are able to identify, so what are the applications of AI, of course, in machine learning or in image processing or in computer vision. So we can find various applications and some of the case studies, and I will show some of the publications also. So based on that, you can understand, so what is the impact of AI for agriculture sector and how much it will help to the farmers in various aspects, that all we discussed in today's session. So before going to the main concepts, first we will see what is the agenda of today's session. After that, we will look into one by one. Based on that, you can understand exactly the overview of AI for agriculture sector. So first we will see basics of AI and applications. We are not going to spend much time for this because these are all very simple things and simple definitions only. And after that, we are going to look into why we have to go for AI in agriculture and what are the applications and what is the significance of agriculture sector in India. That brief details we'll discuss, so that we can find the significance of agriculture as well as AI for agriculture significance. Both we can find simultaneously. And one of the main component of AI is machine learning. Of course, we have various components of AI like machine learning, computer vision, natural language processing, image processing, like robotics. Like that, we have various components. So there, machine learning is one of the major component in which a recommender system is very, very important. How it will play a vital role for agriculture sector. It's a very, very interesting application, and research is going on now also. So many publications also published already, and still research is going on. So that I will show some of the publications, along with I will explain the concept. Based on that, you can enhance further also how recommender system will help to agriculture sector for recommendation of the fertilizers, or maybe recommendation of the pesticides, or maybe recommendation of which crop is suitable to the soil. So such type of things we can learn after end of this recommender system in agriculture. I will show some of the case studies so that I have found in some of the research publications. Based on that, we get more idea about that application. And after that, so case studies and what are the free online tools for recommender system, so that I'll explain. Even you can try after end of the session, you can give input, you can find what type of crop it will, I mean, what type of what we can call it as a fertilizers will recommend to the soil, or maybe what type of crop is suitable for the soil, or maybe that based on the weather conditions. So there's such type of online tools we have that we can utilize for the research purpose, or maybe for doing some survey kind of things. And so after that, how digital image processing plays a vital role for agriculture, because computer vision, image processing, these are also components of AI. That's why we'll see briefly how image processing plays a vital role for agriculture, and various miscellaneous like how the robotics vital role for AI, I mean agriculture. That also we'll see as a miscellaneous cases. And also for further enhancement, if you want to go for AI for agriculture sector, I will show some of the resources you can go ahead with, or maybe other resources also you can go ahead, no issue. But what I have found, that resources I will show. Based on that, you can go in depth of some of the concepts of image processing, or machine learning, or computer vision, or natural language processing, or robotics, etc. concepts, how it will help to the agriculture sector. So that means here we are going to cover machine learning and AI basics, and some mathematics also you will get, and some of the image processing concepts you will get, and some of the computer vision. Like that, so many concepts, I mean, so many domains or so many subjects are incorporated in today's session, but not in depth, but basic things only. Based on that, you can go for further enhancement of this concept, and it's very useful for research point of view also. And the acceptance ratio also a little bit more, because we have a true real world application in this agriculture sector. Because of that reason, so we have some suitable journals for that. If you apply, there is a possibility for acceptance in less time and compared to the other core subject, I mean core domain research articles. Yeah. So coming to the definition, just what is AI? Actually, after Second World War, so Alan Turing changed his history with some simple question: can machines think? So what happens? So after Second World War, so is it possible to mission think? Then what happens? So because of that question, so AI comes to the picture. So that is the main source in 1950s, not even 2000 or 90s, 1950. So just because of one question, he is a mathematician actually. So Alan Turing. So he with simple question. So can missions things based on that. So artificial intelligence, then extension of so many other things comes to the picture. So the basic idea of this AI is, so just we have to make a program for a mission in such a way that it will think and it will act like a human. So that is the main simple definition of AI. When you come to the AI, so what we have to do, computer mission can think like a human just because of program. So whatever programs if we make, and if the system can predict, or if the system can act as a human, then we can call it as that is artificial intelligence. So now why we have to go for artificial intelligence? Because it will act like a human and it will behave and it will go whatever things we are doing, that also it will do. So that's why what are the advantages when you go for AI? Of course, we have pros and cons, but we have most of the advantages of AI because of that reason only. Now AI is the current buzzword. Everywhere if you go, even nowadays BE specialization in AI also, even data science. These are all comes under one umbrella: artificial intelligence, data science, deep learning, natural language processing, machine learning, image processing, computer vision, all comes under one umbrella, and each and every subject depends on other concepts. Then only we can make a product, or maybe we can develop an application for any sort of application purpose. Now here the main advantage is reduction of human error. So when you go through the applications in detail, you can understand what is the meaning of reduction in human error. Because so whenever if you go for humans, possibility to do some mistakes, but when you go for a machine, so when you go for proper input and proper programmed, so there is a very less chance for doing error. So because of that reason, we can try to reduce the human error and reduce the risk, and risk also very less, and 24/7. So we used to work, maybe we are working maybe 8 hours or 10 hours. When you come to the AI, so 24/7. For example, in 12 o'clock night also, if you want to send some message or maybe in chat box, so you will get reply immediately. So of course that side no human being or no employee is there, but you will get the response because of the application. And faster decision and digital assistance, like that we have huge number of applications of the AI. Because of that reason only, this is one of the current buzzword in across the world, and there is a huge demand for this AI also in future also, because of so many applications are there. Now we can see various applications, real world applications. So one is healthcare sector. Whenever if we go to the doctor, so there we can go for diagnosis of the disease automatically. So that is one of the main advantages of application of AI. Even we have recommendation of the doctors. If we enter our symptoms, automatically we'll get which doctor is suitable to based on symptoms. Such type of recommendations also there in healthcare sector. Even classification, this type of things we can do by using machine learning AI. And automobile and finance. So there also everywhere we have this one. So for monitoring, what we can call it as a traffic, every traffic signal you can find this one, and whenever anyone violating the signal, so you'll get immediately notice. Such applications we require this one. Social media, so no need to tell what are the advantages of social media and how much impact of social media nowadays. So their AI plays a vital role. And entertainment, so in entertainment industry also AI plays a vital role. Now we have OTT platform, so their AI plays a vital role. AI means understood that components or maybe elements like machine learning, data science, or image processing, or computer vision, or robotics, etc. All those things comes under artificial intelligence. Anyhow, that we will see in the further slides. Based on that, we can understand what are the elements or components of AI. And education sector also, we have huge number of applications. And space exploration, gaming also, we have huge number of the thing we can do by using AI algorithms or models. Robotics, so we have nowadays we have robotics plays a vital role in most of the sectors. It may be healthcare, or it may be what we can call it as a security, or it may be agriculture sector also, we have robotics. So like that we have so many advantages of robotics also nowadays. Even robotics, because of robotics, now we have virtual wars also happening between countries. And agriculture, so this we are going to discuss in today's session. So AI applications in various sector, in which agriculture also plays a vital role. So that is our scope of our today's session. And e-commerce, So e-commerce means like what we can call it as an online. We used to give order. So it may be Flipkart or it may be eBay website. These are all e-commerce. So there we can AI plays a vital role. It may be recommendation or it may be prediction of cost, etc. So there are huge number of applications of e-commerce only. That application is also very helpful to the customers as well as owners of the e-commerce websites or maybe industries. So, but today's session scope is agriculture. Like that, still we have so many are not listed in this slide, but still we have huge number of applications of AI. Because of that reason only, now this is a current buzzword everywhere. It may be BE or MTech, or if you go for BE specialization, everywhere talking about AI, because there is a huge number of opportunities also there because of these many applications of AI. But we are focusing one of the application that is called agriculture. So how AI plays a vital role for agriculture, and what are the case studies, and what are the models we are going to apply to the application, and what type of output we'll get, and what are the research directions. I will show some of the research publications. So based on that, if you want to go for, if you want to explore in that area or maybe domain, we can go for further, and that's why I will show that resources also at the end of the session. And when you see here, as per MRF research, so AI market to be worth of more than 25 billion by 2025. We can see the 2016, so and 2017, 2018, up to 2019, not that much growth. Slowly it's going, but when you come to 2020, 21, 22, 23, it will reach 25, more than 25, around 30 billions. It may reach possibilities there because of huge number of applications. So here 2023, so almost it will reach 25, maybe it will reach more than 20, 2023 only we can say around 25 billion is also. That's why AICT also introduced B specialization is for the students or specialists in the AI courses and data science and machine learning or AI related domains. Now, what about agriculture in India? So, and we know AI, it's very simple thing is, so we have to make work what we are doing, or it will think like various applications in which we are going to discuss facts, so figures of this AI by $20. It's a huge amount. That's why there is a huge number of opportunities are going to create because of this AI. Now, when you come to the agriculture in India, obviously everyone knows, so almost 65% of the people sustains because of agriculture in India. So we are almost 150 crores. So that means 150 million population. So most of the people, around 65% of the people sustain because of agriculture. So previously GDP of agriculture contributes more, but now it decreased. You can see here 14%. In 1960-70, at that time, we have 45-50% contribution of agriculture to the GDP of the country. Now it's drastically decreased because of so many issues also there. So maybe remuneration, getting manpower is very difficult, and no proper water, or maybe rainfall is less in some areas. Maybe so many other factors also there. Because of that reason, the contribution of the agriculture reduced drastically to the GDP of the country when compared to the previously. But other sectors are increased. That's why there is no issue. So like service sectors, other things. And 50% of the people depends on agriculture. So based on these facts and figures, so it indicates that we have to protect this agriculture, obviously, because huge number of people are depends on this agriculture. So that's why AI plays a vital role for this agriculture sector. So when you apply AI, so that most of the people will get jobs. At the same time, we can increase the crop, what we can call it as a productivity, and also we can get huge amount. Farmers also get huge amount, and based on that, our GDP also will increase, so that we can be competitors for other countries of the world. So like that, we can get huge number of benefits when you implement properly AI applications to the agriculture sector, or AI models to the agriculture sector, because it will behave, or maybe it will act like a human. Because of that reason, most of the problems can be solved by using AI. So, but we will see what are those things. Based on that, we can understand exactly how we are going to apply to the agriculture sector in India, not only in anywhere. So Now we will see how AI plays a vital role in agriculture. Now we discussed briefly about what is AI. We discussed briefly about agriculture sector in India and how much impact of agriculture in India, and also it will play a vital role for GDP. Now how it will play a vital role for agriculture when you come to the AI. So how we are going to utilize based on that, what type of income we are going to get, and how farmers are getting benefit. Of course, others also maybe what we can call it as there is a huge employment can be created because of this reason. Now you can see here artificial intelligence in agriculture. So first one is crop yield prediction. Obviously we can go for crop yield prediction. Based on that we can go for proper crop to the soil. Suppose if the crop yield prediction is not up to the mark, in that case we can try to change the crop, depends on the weather conditions or depends on the soil. So such type of predictions is very useful. And price forecasting. Maybe next year one crop is, let us assume the rice or maybe potato or maybe onion, some crop or maybe wheat, whatever it may be, cotton, the price is very less. Maybe based on that we can go for further crop. Because of that reason farmer is not going to lose. Suppose the price is going to decrease next year as per the model prediction, again he is going to use that, again he is going to put that into the soil, then obviously he is going to lose, and obviously there is a big problem for the farmer. So that leads to suicide, etc. That is happening nowadays in most of the places. So because of that reason, if you go for forecast properly, based on that the farmer will choose which crop is suitable to the soil. Based on that he will get huge income, and there is nothing to worry about other things like other problems to the farmers. And farmers also will get encouragement, so that next time he will do, or he will go for more actively to participate in the agriculture sector crop. So next intelligence playing. So there, when you come to the robots plays a vital role. So if you have huge acres, so it's very difficult to, because of that reason robots plays a vital role. Most of the countries are using what we can call it as an investment, but they'll get huge benefits. But if the land is little bit, we are not going to use this intelligence playing, because that money will take more than this labor. But the land or all those things, if huge, then we can apply this one. And predictive insights. So this is also one of the main. So we already discussed, but I will show some of the images. Based on that we can spraying, or maybe what you're picking the ripe fruits. So such type of applications we have, so that we can go for proper crop, or maybe we can go for proper pesticides and soil defects, etc. we can do, or maybe proper fertilizers we can utilize. So this type of things we can do easily. Or maybe it depends on the season, because if you take Andhra or maybe Telangana, we have Kharif, Rabi, like two main seasons. So obviously we can go for based on the soil monitoring. So in this season we can go for this crop. Let us assume rice, or maybe potato, or maybe ragi, or maybe onion. So this is a suitable. Such type of things we can do easily when you go for soil monitoring by using mission or AI algorithms. And disease diagnosis. So this is also one of the important application. So whenever if you have any leaf or plant having disease, that we can diagnose, or we can identify. Based on that immediately we can take care of the consideration to reduce that one. Otherwise there is a big issue to get the crop properly. And here image computer vision plays a vital role. Computer vision, machine learning, sorry, image processing. Of course, deep learning also we can classification of the disease leads, etc. So all those things comes under this disease diagnosis. I will show some of the research papers also. They're applied for the classification of the disease infected leaf. Number of applications of AI in agriculture sector, but this will give the proper idea Based on that, we in agriculture sector. Even some of the things what we not discussed in previous slide. So here predictive and role, it will recommend to the farmers. So what type of plants we have to seed and what type of fertilizers we have to utilize, or what depends on the soil, what type of fertilizer or maybe pesticides we have to use. So this type of recommendations you will get based on the even what we can call it as climatic conditions also. So this recommendation plays a vital role. So I will explain some of the case studies also so that you can understand how it will place a vital role for agriculture sector. And drone satellites also plays a vital role for this precision farming when you come to the agriculture sector. And soil health monitoring that we discussed in previous one, by using machine learning, deep learning techniques we can use, identifying plant disease, etc. Now, when you come to the artificial intelligence components or elements, so we have main components are machine learning. That is one of the main component of or element of artificial intelligence, and neural networks. Of course, neural networks comes under machine learning, and natural language processing, and expert systems, evolutionary computation, computer vision, robotics, and speech interpretation. So many things are there. We have elements, but we are focusing mainly on machine learning and computer vision. There we are going to discuss some of the image processing applications to the agriculture field. So these are the two things, but other things also we have used number of applications. But because of scope of the session, we are focusing these two components in which how we are going to apply to the agriculture sector. So now coming to the main component of the AI is machine learning, and how we are going to apply for agriculture. One application with case study I will explain, and I will show some of the research papers. Based on that, you can understand in detail how it will plays a vital role. So whenever if I take based on the experience, is it possible to machine can learn some algorithm or maybe a machine learning model? So but data is very, very important. So we should have data. Based on that, machine also can learn. And after that, whenever if we give new data, it will predict or it will go for forecasting. So that's why machine learning comes to the picture. Suppose if you don't have data, so nothing to do with the machine learning models. So that's why, so data is very, very important. Based on the data, it will learn, and followed by, so we can go for testing. Maybe if we use some new data, it will predict automatically. So that's why machine learning basic idea is it will extract the patterns from the data. Based on that, it will go for prediction or classification. But data is very, very important. Without data, we can't do anything. So that's why, because we are in big data era, so we have used data in organizations or companies or industries or maybe academics. Everywhere we have used data. Because of that reason only machine learning comes to the picture. By using that, we can go for so many applications what we discussed in the previous slide. But here data is very, very important. Data is nowadays just like money. So that's why everywhere we have used data. That's why we machine learning, deep learning, all AI, all this comes under picture. And based on that, we can implement the various applications, or we can develop various products. So now, so here, what is the fast data? Based on that, what we are going to do. For example, if we take simple example, let us assume, if we take, let us assume a day, and let us assume number of COVID cases, simple example. So that is the scenario what we faced recently. That is a pandemic scenario. Day 1, day 2, day 3. Let us assume number of COVID cases 15, 14. Let us assume 17. So this is the data. So this is the historical data. We can call it as a historical data. So based on this historical data, so this we can call it as a training phase. So here we have a model, machine learning model. So after that, it will make a program, or we can call it as a model. Let us assume, so regression model, let us assume y equal to, so let us assume 6x plus, let us assume 8. So this is a machine learning model, and based on this data, so we have to make a model, or we have to make a program. We can call it as a program. Now, whenever if I take day 4, let us assume tomorrow I want to predict how many number of cases. So what machine will do? So it will substitute in place of x4, and based on that we'll get y value. So y equal to 6 into 4 plus 8, so that we can find how many number of COVID cases in day 4. So that is the simple thing in machine learning. So we have historical data. It will learn. Based on that, it will make a model. So by using that model, we can call it as a program, or we can call it as a function. So by using that algorithm, or we can call it as algorithm, by using that algorithm, we can go for prediction or forecasting of the future data, or we can call it as a here test data. So just it can substitute based on that. Now the question is why we are not writing program, why we are making like this. So whenever if I go for this type of historical data, it is very difficult to go for a program. It is very difficult to make explicit program. So because of that reason only, so we have to try, based on that it will make a model, then only we can predict. Suppose if you are able to write a program, let us assume sum of two numbers y equal to a plus b. If we substitute a b values, we'll get sum of two numbers. If we here easy to write the program, but for this type of data it is very difficult to go for explicit program. That's why whenever we are not able to go for explicit program, such type of things, so we are going to handle with machine learning. So by using that we can make a model, and hence we can predict the future value. So that's why machine learning comes to the picture. Now coming to the one of the main application for agriculture sector, and with case studies we will discuss. I think so far we completed fundamentals. What is artificial intelligence? What are the applications? What is agriculture sector in India? And what are the applications of AI in agriculture sector? And what is machine learning definition? So just it will look for insights of the data. Based on that it will make a model, and by using that we can predict the value or future value. That is the ML simple definition. Now machine learning, how it will plays a vital role in agriculture, in which I am taking one small subdomain that is called recommendation system in agriculture. So I think most of them knows what is recommendation system. When you come to the e-commerce, e-commerce means like mobile recommendation or product recommendation, such type of things, or maybe streaming services like YouTube. Whenever if you open YouTube, you will get recommendation of the videos, or whenever if you go for OTT platform, you will get recommendation of the videos, or maybe music, etc. So whenever if you go for e-commerce website, you will get recommendation of some mobile or maybe product. So every day we are being influenced with this recommendation system, but we don't exactly what is happening beyond that. But we should know what is recommendation system. Based on that, how we are going to apply for agriculture. So recommendation system plays a very vital role in agriculture sector, like e-commerce and streaming services. Streaming services means like entertainment. So there, how it will play a vital role. So that means we are being influenced with this recommendation system every day, but we don't exactly happening beyond that. So that is the main thing. But after completion of this session, you can understand how it will play a vital role for even streaming services or e-commerce. In similar way, we are going to discuss recommendation system in agriculture sector also. So we have huge number of applications, and we are going to get huge benefit because of this in agriculture sector. Now you can see, so whenever if I take recommendation system for farmers, that will help them in making informed decisions. So what we do here, recommended crop to be planted. So whenever if I take recommendation system, so what type of crop you are going to plant. So for that we have to go for recommendation system. So what type of fertilizers we are going to use for, based on the weather conditions or based on the soil condition. So for this it will provide the answer. So it will recommend what type of fertilizers we are going to use for the soil, depends on the soil condition or weather conditions. And prediction, yield predictions. So based on the seasons or the geographical location, so it will recommend what type of crop it will yield better, but that type of recommendation it will give. And real-time data, what is happening inside the soil, so that recommendation also it will provide. Of course I will show some of the online tools also. Based on that we can execute later also. And automatic irrigation system also, so it will recommend. So like this we have huge number of applications or benefits when you are applying for recommendation system, and farmers will get these type of benefits. So otherwise they will be the losers. Suppose sometimes if you are not going to do proper crop to the soil, or maybe if you are not able to do proper crop, depends on the weather conditions, so it's a problem. Then suddenly it will collapse and nothing will get whatever is spent for money to the crop, nothing he will get returns. Because of that reason sometimes he may lose huge money. So because of that reason AI plays a vital role, in which recommendation system will try to do this type of answers to these questions. So but exactly how to do this one, and what type of machine learning models will apply to these to solve these type of things, that we will discuss in the further consecutive slides. So these are the motivations for choosing this topic. So motivation is first one, a recommended system for agriculture in Mali. So this is one of the, sorry, one second. So one of the research article motivating to choose this one. Collaborative recommendation system for agriculture sector. Anyhow, one of the paper I will explain in detail system for precision agriculture. So like that we have used here also you can see. So agriculture recommendation system ERS. So here also how the recommendation of the specific crop depends on the soil. So whenever if we give some input data, whatever data we have, maybe it may be soil information or maybe weather information or maybe crop information. So if you provide, it will use or it will recommend which crop is suitable. Such type of things this agriculture recommendation system will provide. And recommended system for farmers. This is also the objectives almost same. The questions what we have raised before that. So by using recommendation system, that answers will get by using these application. I mean these research articles. So these are the research articles motivated me to choose this topic because we have huge number of applications of this one. Now anyhow, I will explain one of the paper. Based on that you can understand so how it will play a vital role for agriculture sector. So basically what is the recommendation system here? So this is I'm giving here generic, later we will go for specific. So once again I'm telling whatever recommendation system concept I'm explaining time being, so that is generic. Once if we complete this recommended system, I'll go to the specific only for recommended system for agriculture sector. I will show some of the case studies and research articles I have already shown, but again I'll explain one by one. So this is the huge data. Let us assume this is the data set and this is my data. This is my interest. So let us assume these are the movies. Maybe let us assume comedy movie, action movie, and so that you can understand why I'm giving these examples. You can understand. That's why I said it's a generic. Later we'll go for specific to the agriculture sector also. So we have action movie, comedy movie, thriller movie, maybe romantic movie like that. So my interest is only comedy movie. What this recommended system will do, it will filter all the movies which are not interest to me. So because of that reason, which are not interested, so only it will filter the movies, or it will recommend only the movies which belongs to comedy, because my interest is only comedy. So rest of the categories will filter and only the comedy movies will recommend to me. So after that, whether I am going to watch or not, that is left to me. So just recommendation system will filter the information depends on the interest of the customer, and based on that it will recommend. So whether the customer is going to watch, whether customer is going to buy, that is left to the customer. So that means the basic definition is it is a filtering system, or we can call it as an information filtering system, and based on the interest of the customer or user, it will recommend items or maybe products, or it may be a crop, or it may be movies, etc. So this is the basic recommended system concept. So why we have to go for recommended system? So nowadays we have huge data. We have we are in big data era. So we can't search each and every item. When you go for recommended system, automatically you will get. Suppose if you open YouTube, immediately you get some of the videos recommendation. Suppose if you open OTT platforms, it may be Amazon Prime, or it may be Aha Telugu OTT platform, or maybe Netflix, whatever it may be. If you open, immediately you get some of the recommendation of the videos. So this is the main advantage when you go for recommendation. But our scope is how we are going to apply to the agriculture sector. Based on that, what are the benefits we are going to get. Now we have a huge number of applications that I have said in the previous slide also. Streaming services like Netflix, Amazon Prime, and agriculture sector. So this is our scope that we are going to discuss. That is one of the main application of recommender system. And e-commerce like Flipkart and eBay, Amazon, these are all comes under e-commerce website. There will get recommendation of the products, etc. And healthcare industry, in healthcare also you will get a recommendation of the doctor, recommendation of the drugs. Drugs means here tablets. So it depends on the disease or depends on the issue, you will get recommendation of the drugs. And social media, every day whenever if you open Facebook, you will get recommendation of the friend. So some X person recommended for you, whether you are going to accept or whether you are going to send friend request is not or not, is not, that is left to you, but you will get recommendation in social media. It may be LinkedIn or Facebook, etc. And job recommendation, based on your profile you will get automatically recommendation. We have so many job websites. So whenever you upload your profile, so based on your profile, whichever jobs are suitable or whichever jobs are matching, whichever jobs are similar to matching to your profile, automatically you get recommendation. And education, based on your percentage, some of the universities will get recommendation, please join, like that. Such type of things also we can do by using recommended system. E-government, tourism, etc. Like that we have huge number of applications, and we are going to discuss how it will play a vital role to the agriculture sector. So basically we have three types of recommender system. One is popularity based recommender system, and content based, collaborative, and hybrid. Hybrid means it's a combination of any two or maybe three, but basically we are going to focus on collaborative filtering. I have shown one of the research publication, collaborative filtering technique for recommended, farmers, or collaborative filtering technique for agriculture sector. Like that I have shown one of the publication. So that publication I'm going to explain how it will play a vital role. Now, what is the meaning of popularity? So, what it's whenever if some video is trending, automatically you'll get recommendation. For that, no need to go for any specific algorithm. The popularity means whichever is more trending, automatically you will get. That is called popularity based. Suppose let us assume some movie, and most of the people are waiting for that. That it's the most awaited movie. Then, whenever if they release the trailer or maybe a theoretical trailer or maybe a video song, etc., you will get automatically recommendation. So, such type of things we can call it as a popularity based recommendation. But what about content based filtering technique and collaborative? But in agriculture sector application, what we are going to discuss in today's session, I'm going to explain collaborative filtering technique. And hybrid means we can go for combination. So here collaborative filtering, let us assume I'm taking users, or maybe he is one farmer and he is, maybe one A user is one farmer, B user is one farmer, or maybe you can assume two customers. So both watched the movies, let us assume Crack and KGF. I'm telling generic. Later I'll come to the specific for agriculture sector so that you can understand. So movie, this type of things means you can remember easily. So both watched the movies. So what it indicates that both are similar users. So whenever both are similar users, whatever movie watched by A, then automatically that movie will recommend to B. So this is called collaborative filtering. So this collaborative filtering technique we are going to apply for agriculture sector. So how it is applicable, I will show with data set. Based on that you can understand. So simple thing is, so maybe let us assume A is one, farmer, B is one farmer. So both are trying to put a crop on some, let us assume maybe wheat or rice or something, and maybe let us assume with the same soil conditions and weather conditions, maybe A also looking for such type of thing, maybe some other crop, then same type of crop will recommend. Or maybe fertilizers, maybe one customer or one user already bought some fertilizers which is related to one of the disease, and one more customer also having such type of disease for the crop, then automatically the recommendation system will recommend such type of fertilizers to the customer or maybe user. So that means whenever there is a similarity between farmers or users, so based on that it will recommend automatically. Here what happens, so both users are similar, whenever she watched Bahubali, same thing will recommend to B. For example, if B watched some movie, let us assume some movie, Y movie he watched, then automatically that movie will recommend to A. So let us assume B watched some latest movie, then automatically it will recommend to A. So that is the concept of collaborative filtering. But we are going to apply for our agriculture sector also collaborative filtering technique, how we have to recommend crops, or how we are going to recommend fertilizers, or how we are going to recommend pesticides to the customers based on the similarity between soil condition or weather condition. Like that type of things we have to look for similarity. Of course, there are some mathematical models required for checking the similarity between two items or maybe two list of items. So based on that, it will recommend automatically. So now we will see later how we are going to apply for. And content based, we are not going to discuss for agriculture sector in today's session. But I will explain what is content based. So whenever if I take, let us assume A watched the movies, both are comedy genre or maybe comedy category, and he used to watch only comedy. Whatever movie he watched, both are comedy category. Understood that in his profile only the comedy movies are watched like that. That information is stored. Now, whenever if I take latest as a movie 3, movie 4, movie 5, these are the movies released in the OTT platform. So based on the past activity, what happens? He used to watch only comedy, hence it will recommend comedy movie. That means movie 4, it will recommend to the customer. So this is called content based. That means based on the past activity, it will recommend. For example, farmer, let us assume A is a farmer and he used to buy only one type of fertilizer to the soil, whatever it may be fertilizer, he used to buy. So let us assume these two are fertilizers. Whenever new fertilizers are available in the market or maybe released in the market, that fertilizers will recommend to the customer. Maybe he is looking for fertilizers, maybe because of he required more for fertilizers, so for his soil. Because of that reason, whenever any new product is released, that is a fertilizer, automatically it will recommend to the customer. So such type of things we can do content based filtering. That means based on the past activity, it will recommend automatically to the customer. So especially this is very useful when you go for e-commerce websites. So suppose if you are used to always order mobile phones, then whenever new mobile phone released in the market, then automatically you will get such type of mobile recommendation. Or maybe always you used to watch, let us assume, some action movies, then whenever action movie released in the OTT platform, such type of movies you will get recommendation. So that advantage is, suppose sometimes if you don't know movie is released, but you will get recommendation. Because of that reason, you will open and you will watch. So that is the advantage when you go for this type of content based. But in today's session, we are going to focus on collaborative filtering for recommendation of agriculture sector. And here we have user IDs or farmers, items, whatever fertilizers or maybe whatever other things they purchased so far, that information rating is available, that we have to make it as a utility matrix or user item matrix. Or a user means here farmers. So here we can call it as a user 1, user 2, user 3, user 5. We have 5 users in the data set, and whatever rating given by the users. User 1 gave rating 5 to the item 1, and the ratings not given by user 1 to the other items. Maybe he did not purchase these items, that's why there is no rating. And user 2 gave rating for all the items because he already purchase these items, that's why the ratings given by user 2 is this one. So wherever empty, understood that he did not purchase that one, or he did not watch the movie, that's why there is no rating given. So that means when if I take users are nothing but farmers, so items are nothing but some kind of attributes like fertilizers, etc. So in that case, whatever rating given by the users, that is for fertilizer items what he purchased in the shop, like that, or maybe through online, whatever it may be. So this is called user item matrix or utility matrix. Later you can just hold this utility matrix. Later we will see how it is going to helpful for recommendation to the agriculture. So this is a basic idea. So we have field data, whatever it may be field data. So it may be weather conditions, or it may be soil conditions, or it may be rainfall conditions, whatever it may be. So that is the input, that is called field data. And after applying machine learning, it will recommend crop recommended. So which type crop is suitable to the soil. So that type of recommendation will get. Not only crop, other things also we have. So what type of fertilizers we can recommend, what type of pesticides we can recommend. So this type of things it will recommend automatically. Because of that reason, so farmer will get huge advantage. If there is no recommendation, then if you do some mistake, obviously it's a big loss for the farmer. Because of that reason, so this plays a vital role. Based on that, you will get money, and there is no loss for that. So now here we are going to use some PCC method for calculating for recommender system. Hello.
Sir,
Hello, sir.
small interruption. Sorry for that, sir.
At
7:50 to 8 o'clock, give small break, sir. After that, you start.
Okay.
Okay,
okay. 10 minutes left, no, sir. Still 10 minutes left.
Okay. So you start the 8 o'clock, sir.
Yes, sir. I think now 7:48, no, sir. Can I take 5 more minutes, sir?
Yes, you take 5 more minutes and you 10 minutes break.
Yeah, after that I'll give.
Okay, sir.
Okay, sir. So I'll take 5 more minutes. After that I'll use.
Okay, sir. Okay, thank you.
Fine, sir. Yeah. Okay. So this is the data set. So I have said already, when you go for collaborative filtering, we have to look for similarity between users. Based on that, it will recommend the movies or maybe products automatically. But when you come to here, let us assume this is the simple data set I'm considering for better understanding for recommendation of the fertilizers or maybe crop recommendation to the farmer. So let us assume farmer 1 to 4. These are the 4 farmers, and the attributes, whatever it may be, A1, some weather condition, maybe rainfall, or maybe fertilizer information or soil information. Some attributes I am assuming A1, A2, A3. When you go to the data set, you can see what type of attribute names, that also I will show. So A1, A2, A3, A4, A5, A6, these are all attribute names, and the values also available here. Some values maybe rainfall, or maybe let us assume fertilizer code, or maybe something data we have, some numeric data available. Now what happens? So this farmer 1, farmer 4, these farmers data is already available. So these 4 farmers are already available and data is available for all the 6 attributes, whatever it may be name of the attributes. Now Ramu, let us assume, is the active farmer, new farmer, and he entered the information for A1, A2, A3, A4. That means, so these 4 farmers having, each farmer having already information. So maybe based on these attributes, so what type of crop and what type of crop they, I mean, productivity they got, and what type of fertilizers they use. Based on that, they got huge benefits or maybe huge productivity. All those things that data is available, or maybe what type of fertilizers recommended based on this data, soil information, other information, or what type of pesticides are recommended to the farmers. These data is already available because farmer 1 to farmer 4 are nothing but historical data. Now Ramu is a new farmer, he is the active customer, or we can call it as active farmer, and he entered these values, whatever attributes available here, that values entered. Now what we have to look, so whenever if I are looking for collaborative filtering, we are looking for similarity between farmers or users. First let us assume I am looking for similarity between Ramu and farmer 1. So we have to calculate, you can see here, similarity between AF means active farmer and farmer 1, 0.86. For calculating a similarity, so we have to use correlation coefficient. So by using correlation coefficient, we can calculate the Ramu and farmer 1 value. 0.86 means 86. And we have to look for similarity between AF. AF means active farmer Ramu and farmer 2. That similarity is 51. That means 0.51%. And similarity between Ramu and farmer 3 is 0.49, 49%. Similarly, farmer 4. You can see here, there is a similarity between Ramu and farmer 1 is more when compared to other similarity. Whenever if I take Ramu and farmer 1, similarity is 86%. I already gave example for movies also. Whenever both users watch same kind of movie, whenever other user watched the movie, that movie will recommend like that. So both are similar. When you come to the other farmers, they are not, that he is the active farmer, but other farmers are already having historical data. Now what happens, whatever fertilizers or whatever crop recommended to farmer 1, same thing will recommend to Ramu. Why? Because Ramu and farmer 1 are both similar. That means they have similar qualities, they have similar features, they have similar attributes of the soil or weather condition, rainfall, whatever it may be. So because of that reason, whatever crop or whatever fertilizers or whatever other things recommended to the farmer 1, that is already available because that is the historical data in the data set. In data set, I will show later after the break also. So whatever things are available, same thing will recommend to Ramu. So that means you can see the conclusion, the crop or fertilizers prescribed for this farmer, that means farmer 1, can be recommended to AF, that means Ramu. So this is the advantage. That means already we have historical data and he got huge benefits because of recommendation of, because of that reason, whatever data which is coincide with farmer 1, same thing will recommend to Ramu. Whatever it may be crop or fertilizers recommended, same thing will recommend to Ramu also. This is one simple recommendation system in which we are looking for similarity. We have other things also. By using that, we can look for crop recommendation or maybe fertilizers recommendations or maybe other kind of recommendations that also we can do by using this recommendation. So this is the thing what I have explained, collaborative recommendation system for agriculture sector. And we can apply various algorithms. I have applied here similarity between 2 users. Here you can see that formula also. So correlation coefficient between X, Y. X is one user, Y is one user. X is actually active user, that means new user. Y is the already existing user. We have to find the similarity between 2 users based on the highest similarity, whatever it may be other things recommended. Same thing will recommend to X only. So that is the first case study. So based on that, how we are going to recommend the fertilizers or crop to the farmers based on the historical data by using any one of the machine learning model. So can we go for break, sir?
Yes, sir. Yes, sir. Yes, sir.
Yeah. So just we completed one case study with the recommendation of the fertilizers or crop. We will see a few more, and after that we'll move to the image processing applications and computer vision and robot applications. Like that, we have huge number of concepts also. We'll see one by one. Okay. So take a break. After that, we'll come to
You
the
start
some
the
of the
8,
online
8
tools.
5 o'clock, sir. Sir.
8, 5. Yes, sir.
8 5, sir. Okay, thank you, sir.
Okay,
Dear,
sir.
dear participant, please stay back. So. So welcome back, participant. Sir, you start the session, sir. Sir,
Sir?
please start the session, sir. Please start the session.
Yes, sir.
Thank you, sir.
Hope my screen is visible, sir. Full screen.
Yes, sir. Yes, sir. Visible, sir.
Okay, thanks. Yeah. So I think so for what we discussed for this recommended system for farmers, it may be crop or fertilizers. We are looking for similarity between the historical data farmers and existing new farmer, or we can call it as active farmer. Whenever the attribute value recommendations done by the historical farmer, same thing will recommend. That is the thing what we done so far. Now, this is the one more main paper that is called collaborative, because we are talking about collaborative recommendation system for agriculture sector only. So this is a basic block diagram if you are looking for a block diagram. So this is a user, we can call it as a farmer. We are talking about agriculture sector farmer, you can see farmer also. Maybe we have to do profile registration. All those things just for a security purpose, and user item matrix that I have shown. Why we require user item matrix, you can see in previous slide. This is called user item matrix only. So we have all the information, and we have to compute the similarity measure. Just now I have explained, we have to look for already existing farmer attribute values and active farmer. Active means new farmer, it will recommend. So based on the fast farmer recommendation, it may be fertilizers, it may be crop, which crop recommended, or it may be fast farmer, whatever it may be, that same thing will recommend to the new farmer. So that is the block diagram of CRSAS, so collaborative recommendation system for agriculture sector. So I have already explained, just I'm showing the block diagram. Maybe sometimes we have rating also. So based on the rating, whenever if we have similar rating, so two customers having similar rating for same item, then whenever if that customer is trying to go for new fertilizer, same fertilizer, we can go for recommendation to the customer. So we can see rating matrix, that we can call it as utility matrix, we can make later. So scheme ID, scheme means like we can see micro irrigation scheme, something is the prime minister Kish scheme, like that. Something is there in data set. So that's why here we can make it as a scheme ID and rating. So based on the rating, whenever two users rating are similar, then based on the one user recommendation, or maybe one user whatever item is going to purchase, that item is going to recommend to the other user. So that type of things also possible when you come to the recommendation of the items, or maybe crop, or it may be fertilizer or pesticides. And you can see this block diagram, this I have explained also. For example, farmer A, farmer B, farmer C, farmer D. So farmer A is searching for the screen crop and soil. And when you come Okay. Maybe disconnected my tissue. I'll join again, sir. So is it clear, sir, now? I'm audible, sir?
Yes, sir. Yes, sir. Sir, sometimes your voice is not clear, sir.
Maybe signal issue. Yeah, signal issue. Yeah.
Okay. Okay, sir. Okay.
Now my slides also visible now, sir?
Yes, sir. Now, okay, sir. Now.
Yeah, fine. Thank you. Yeah. So here we have to consider soil characteristics, and that we can call it as a columns or attributes of the data set, and environmental characteristics, and we have to do some pre-processing, maybe missing values we have to fill, that we can call it as an exploratory data analysis we have to do, and we have to apply machine learning algorithm, and we have to make a model, and we can go for recommendation. So for some testing data, you can see down here crop recommendation. So recommended crop for the month of May in Bihar is potato and orange, like some of the crop recommended to the farmers. So this is also one of the crop recommendation based on the soil characteristics and environmental characteristics. The attributes are having various parameters, I mean various characteristics, but in this paper considered soil characteristics and environmental characteristics. Based on that, potato, orange, barley, etc. recommended to the farmers. And this is one of the online tool, so Harvestify. So this is one of the machine learning based website. Here I am giving later I will share this website also. So when you click this one, so what it will do, it will recommend the best crop to grow. That is one recommendation it will do. And fertilizers to use, which fertilizers you have to use for the crop or maybe soil, that is one recommendation it will do. It will detect automatically disease. So any crops having some disease or maybe any leaf of the crop having disease, it will detect automatically with the help of machine learning model along with some image processing techniques also. So I will show one of the online tool, this one. So when you click this, we have, when you open this website that is called hervestify.herokuapp.com. So when you click this one, so we can go through the website and you can find these like this: crop, fertilizer, and crop disease. When you click this crop, so recommendation of the crop, we can find like this table or maybe registration form like this. So nitrogen, we have to enter the value, phosphorus, potassium, pH level, rainfall, state, like that. And when you click this predict, you will get recommendation of the crop. I have entered some sample data, and after that you will get recommended. You should grow kidney beans in your farm. So that means it basically recommends based on the soil condition for what kind of crop you can grow in your farm. So this is one of the simple online tool. There if we click, automatically it will give the prediction of what kind of crop you can grow in your farm. And second one, so what type of fertilizers we have to use for the soil depends on the condition. Here we have to enter nitrogen, some whatever it may be randomly we can enter, and phosphorus, potassium, etc. So crop you want to grow, and when you predict this one, you can see I'm entering 34, 12, the 25, and crop you want to grow papaya. When you click the predict, we can see here. So what are the fertilizers required for the soil based on that crop. So maybe something is here. These words also we can't understand because these terminologies are new to us because of this agriculture terminologies. But these are the fertilizers recommended to the customers based on the data or based on the information or based on the attribute values provided by the customer or maybe farmers. So that is one of the recommended system online tool. And here we have to find out which disease has been taught by your plant. So because whenever if I go to the crop, we have various disease possibilities are there. For that, we have to take that image in one of the plant image we can take, and we can save it in the desktop. We can click choose file, and I have chosen this leaf file. When you click predict, we can identify so disease bacterial spot, so and crop is pepper, like that we can find all the details. Based on that, we can go for fertilizer, which fertilizers or maybe which pesticides are suitable for this disease, like that we can identify. This is one of the simple recommended system based on the infected plant, and it will identify the disease and what type of pesticides or fertilizers or maybe whatever it may be suitable to that cure the disease, it will recommend. So in our case, we got like this bacterial spot like that. So this is one of the simple online tool. You can go through that and you can find, it may be recommendation of the crop or recommendation of the fertilizers to the soil or recommendation of the what we can call it as what type of disease the plant having, and based on that what we have to do or what type of things we have to use. All those things will get recommendation automatically by using machine learning algorithms. And in general, when you go for performance training, we have to do testing training. In general, 80% testing, 20 or 70-30 depends on that. So this is not required. Yeah. Now we'll move to the one more important application of AI in agriculture sector, and image processing also, that is computer vision, image processing, all those comes under one umbrella, how it will play a vital role for agriculture. So what we discussed so far, machine learning, one small domain we consider in machine learning, that is called recommender system, and based on that how we have to recommend crop, how to recommend fertilizers, how to identify the leaf disease, what type of leaf disease or leaf plant disease, and based on that what we have to take care, all those things we discussed. Now, how image processing plays a vital role. There is a huge number of applications of image processing in agriculture. This is also comes under AI only because image processing also one of the component or maybe one of the step in AI. So basically the image processing, what it will do, so we have a digital image and we have to process by means of digital computer. You will go for better pictorial representation, or maybe we can go for better efficient storage. But here we are looking for images. When you go for drone application or robot application, we are looking for better pictorial representation, or maybe segmentation or image analysis. This comes under image analysis, segmentation and detection, classification, all those things comes under image analysis. So finally, based on that, we can go for exactly what we are going to do in the agriculture sector. So basically, we are going to take input image and we have to process so that we'll get output image. By using this output image, what we are going to do, that we will see now. So just leave it. This is the basic. So basically, image is nothing but matrix. So let us assume this is the image, which is nothing but matrix. We can call it as a digital image. So each pixel value is nothing but color. Depends on the color it will take. For example, if we take, let us assume A equal to, let us assume, so 40, 50, 70. This is the image. And what is the meaning of 40, 50, 60, 80, whatever it may be values? These are nothing but intensity values or color of an image. Whenever if I take any image, it may be crop image or it may be infected leaf or infected plant image, whatever it may be. So directly we can't process. That's why we have to go for digitization, or we have to convert into digital image. The digital image is nothing but matrix in which each element represents a color or intensity value of image. Now we can process this matrix for further application or further step. So that's why once if we have a matrix, because this is one of the data structure, so when you go for further step, easily we can do. Directly image is very difficult. That's why we have to do digitization. Based on that, we can go for further application. Now, when you come to the application of image processing technology in agriculture, so we can go for monitoring crop growth. We can go for one of the application of image processing. We can monitor by using plant or maybe plant image or maybe leaf image, whatever it may be. And we can go for diagnosis of disease. We can identify the diagnosis. I mean, we can identify the disease of the plant. Whenever if I take any leaf having some disease, that image we can take, and by using image processing techniques, we can identify whether the leaf having disease or not. After that, we can go for diagnosis. So such type of things we can do by using image processing, and monitoring maturity and identify crop colors. All those things we can do by using. Here everywhere we are going to use image only. So we have to take input image. So based on that, we can go for these applications, and classification of crops. All those things we can do. So when you come to here, the image processing having, so monitoring of crop growth, so how much percentage here you can see here, so 30%, and diagnosis of disease around 22%, and monitoring nutritional status, that is very less, 14%, and maybe identify crop colors, that is the rest of the percent. So again, we have different colors that we can go for 17 and 16. So like this we can divide the entire image processing for various applications percentage wise. That means we have huge number of applications in agriculture by using image processing techniques. So let us assume interplant weed detection. So what is the meaning of weed? These are all new terminology for us, frankly speaking, because we are not belong to agriculture sector. So weed means, so you can see I written definition also. Even when I prepared these slides, I don't know what is weed also, frankly speaking. Weed is nothing but a wild plant growing where it is not wanted. That means unnecessary plants are nothing but weeds. So in Telugu, we can call it as a kalupu mokkal antaru. So we can call it as kalupu mokka. So that means whenever if you don't want, we have to remove. If you want means then the crop will destroy. Because of that reason, we have to go for weed detection. So how we are going to do weed detection? If you take this image, so these things are, this is the actual crop, what we are looking, this is the actual crop. So these things are nothing but weed. So unnecessary plants that will destroy the crop prediction, that means crop productivity. Because of that reason, we have to remove. In general, because I am also came from farmer's home. So whenever if you go for any crop, it may be sugar cane or maybe rice, etc. After 1 month, after 2 months, we'll try to remove that weeds. So like that, whenever if you go for automation by using image processing techniques, we can try to identify whether weeds are available in the plants. Based on that, we'll try to remove. So how to identify that, whether available or not? We can see here by using image processing techniques, we can identify this area having some weed, and this area having some weed. Weed means unnecessary plants. So obviously, if you encourage such type of weeds, then it will destroy the productivity and you will get less crop. So because of that reason, the crop prediction we have to increase. I mean, the crop we have to yield more. Because of that reason, we'll try to remove this type of unnecessary. So wherever white color is there, so that is the weed that we have to remove here. So final output after filtering showing the weed affected areas as a white blocks. So white blocks here, these are the blocks, and you can see in the original image also, this is one white block. This we don't want, we have to remove. Here also some weeds are there, this we have to remove. So this we can detect by using image processing technique. So this is the actual algorithm. Input image, that is the image having weed, whatever it may be plant in which we have weed, that we'll try to identify. Based on that, we can remove later, and we have to go for detection of weed blocks. So we have to do base color, we have to do pre-processing, we have to do image analysis, and we can do post-processing, depends on the application. So finally we can go for segmentation or detecting the weed blocks. So if no weed blocks found, understood that, so the crop is growing healthy and there is no need to go for further action. If we find some weed in the crop, understood that it is, we are not going to get good benefit or maybe good productivity or good outcome. So we have to remove this weed. And here we can go for insect and plant disease detection. So we have plant diseases. When you take here, so we have a disease, and understood that that area also we can identify easily. So some fungus is available for the plant, and each leaf having some fungus. How to identify? Based on that, maybe you'll get recommendation of some fertilizers. So finally identified some fungus, followed by this type of fertilizers we have to use. Such type of applications we have, or such type of apps also we have. When you come to the agriculture sector application, it's a combination of image processing and machine learning. Of course, both comes under components of the artificial intelligence. And here we can identify, so computer vision system for insect detection. So these are all some kind of insects. So we have to identify, we can go for proper pesticides so that it will die. So our aim is to kill this type of unnecessary things. So this type of unnecessary insects, that's why we have to go for pesticides, and automatically the system will recommend this type of pesticides we have to use so that we can kill this type of insects. So this is also one of the image processing plus machine learning. We can apply deep learning also. By using deep learning also, we can identify, and based on that we can go for further diagnosis. And whether the fruit is whether the vegetable is ripe or not. So whenever if you go for automation, like when you go for robotic automation, so automatically the robot will pick. So if the fruit is ripe, then it will pick, otherwise not ripe means it won't pick. So these fruits we can see here, it is grown. Ripe means grown. So everything is developed properly, we can ripe. So if you take this one, not ripe. So this type of things also we can do by using image processing plus machine learning application. So image processing we required here. If you want to do any pre-processing, we require image processing. Or after that, we can apply the deep learning techniques or image analysis. Based on that, we can detect so which fruit is ripe, which fruit is not ripe. Based on that, the robot will pick automatically. I will show that image also, how some of the countries are using efficient picking the apple or maybe other vegetables, those were ripe. Otherwise, it won't pick automatically, it will avoid. So you can see down some of the other vegetables also, or maybe fruits also, which are not ripe. So that's why no need to pick this one. So this is also one, because nowadays automation, most of the developed countries, they are using this automation. So no, because their labor issue is there, because in our country we have manpower, but most of the countries, they don't have manpower much. So because of that reason, they are using automation. So that is called smart farming, and automatically robot will go and it will pick and it will make a storage in proper, and after that it will send to the other countries, maybe other places or market, whatever it may be. You can see here a fruit picker. This is the actual robot. So a fruit picker and ripe fruit and computer image. So because here everything is fixed here. So this is the robot and everything is fixed. So it will detect the image, and wherever ripe fruits are there, it will catch, it will pick, and non-ripe or not ripe fruits, it won't pick. So that is available here. You can see here. So these are the not ripe, and these are all ripe fruits. So automatically it will pick. So this is a simple robot application. Their image processing and machine learning comes to the picture, and they will fix what type of how it has 5 degrees of freedom. If you go through these articles, you can find exactly how they are making this one. Just I'm giving the basic idea. After that completion of the session, if you go through this complete information, so how many degrees we have to go for picking that one, and where we have to store, and so many things are there. Of course, some issues also there. So that we can find exactly when you go through the publications. And here you can see this is an autonomous boat ropes greenhouse looking for ripe peppers to pick. So some of the countries using this one. Some peppers are available here. I think it's not that much clear. So you can see down images. So peppers are available, and automatically, so it will peak whenever ripe, otherwise. So as per the research, it will work around 20 hours per day. So you can imagine. So suppose if we want to keep labors, then how many labors we required? It's a huge manpower. So, and also we have to spend huge amount. Because of that reason, when you go for this type of automation or maybe smart farming, automatically we have to accommodate one robot, and automatically 20 hours per day it will work. Maybe rest of the 4 hours maybe for maintenance or maybe some other technical things we can take care. So automatically we can complete our work maybe within 1 day also. If the land is huge acres, then it will take a little bit time. If the land is little bit, maybe we can complete within 1 day only. So but if you want to go for manpower or labor, it will take a huge amount, and we have to spend a lot of time also. So here also you can see, so Israel startup, tomato picking boat. So Israel already started this one. So how to go for tomato picking? So the tomato is ripe, so automatically it will pick. If the tomato is not ripe, then it won't pick. Here you can see some of the tomatoes are not ripe, and these tomatoes are ripe, so automatically it will pick. And experts expect the agriculture robots market will reach 75 billion by 2025. You can see here 75 billion. It's not small amount. It will reach 75 billion by 2025 only in the agriculture sector. So there is a huge that's why there is a huge demand for AI specialists or data science specialists because of these many applications. That's why they are getting huge in salaries also. Nowadays, there is a huge salaries offered for these specialists because of these many applications. And of course, they are also getting huge amount because of that reason only. So nowadays, most of the students are looking for AI or data science. And if you want complete information of these details, you can, I have shared here YouTube. If you type in YouTube, we can find complete information of this robotics, how they are doing picking the tomatoes based on the ripe or not. And yeah, this is also one thing, agricultural vertical farming technology. So here also, so farmer use smart farm automation robot assistant image processing for detection weed and spray chemical. So I already said, so weed is nothing but unwanted plant which will in general grow between the actual plants. So that we have to remove. That means automation robot. This robot will automation robot assist to remove that weed, or it will go for spray chemicals. When you spray chemicals, automatically it will die. Then obviously actual crop will grow properly, and it will use the proper outcome. That means proper productivity it will give. So because of that reason, so we have to go for automation robot. So most of the countries they are using this one. That's why I have shared one of the image also. So we have robot here, and it's spraying some chemical. You can see here some chemical is spraying wherever there is a weed. If there is no weed, then it won't spray any chemical because not required. And automatic identification of plant. So here some disease is there. So ESCA disease, that is one of the disease. So by using image processing technique, we can segment that area. We can see segmentation by using pre-processing and image analysis. Then finally we can segment, and we can identify, okay, this plant or maybe these leaves having this disease, and based on that we can go for diagnosis. Maybe immediately we can go for pesticides we can do, or we can spray pesticides so that we can control this type of disease. But we should identify whether there is a disease or not. So because of that reason only, image processing, that means AI plays a vital role. So once if you identify it, then we can go for pesticides. Without identify, how can I know? So we have to apply pesticides or not. That's why that automation plays a vital role. So here also similar kind of thing. So we have some of the diseases for these plants or leaves, and we have to go for further pesticides. So based on the segmentation or analysis recommended by the machine learning or image processing techniques. And this is strawberry harvesting robot. And obviously here also similar application only. So whenever ripe, it will take, otherwise it will leave. So this is here also robot. Most of the countries using this type of robots. So just I'm checking whether disconnected or active. That's why I minimized. This is strawberry harvesting board. I will start screen and slideshow. Now here, this is also one weeding. So that means weed is nothing but unwanted plant. If you want to remove, we have this type of automated vehicles. So it will remove automatically instead of putting labor. So because labor cost is more, to minimize that, so we can go for weeding by using a Hearty bot. So that is one name, that one robot. That is the name of the robot. Here also we are using automation. And here, this is also one of the important application. So if someone is looking for what we can call it as a trying to take some crop, or maybe trying to destroy something, or maybe we can call it as human breaches, is trying to take something from the soil. So in that case, so it will detect automatically, the surveillance will detect automatically, and it will send information to the owner. Based on that, it will can take action immediately. So that means this type of monitoring system also available because of AI application. So you can see here it is identified automatically. So a person, that accuracy is 99.60, understood that maybe is trying to do some unethical activity here, maybe whatever it may be, we don't know why, but the surveillance will identify, and it will give information to the concerned person. Even animals also, if any animal trying to take trying to destroy the crop, so that is happening in general in villages also. So at that time, it will send message immediately to the concerned person, then he will take action. Otherwise it will destroy entire crop, then it's a huge loss to the farmers. And price forecasting, this is also very one of the important application. So we have to go for price forecasting. So based on the yield rates that help predict total volume of produced invaluable in defining price strategies for a given crop. So why we have to go for price forecasting? Suppose I have one crop, so maybe if I'm looking for forecasting, the price is little bit more, maybe next month or maybe in future. Obviously, we can go for such type of crop. Suppose if the price is less, maybe farmer is going to get huge loss, then no need to go for such type of crop. So no need to go for such type of crop. Because of that reason, price forecasting also very important. Now the question is how to go for forecasting of the price. So, or maybe how to forecasting something. So for that we have to go for regression. So now we have seen some of the image processing simple applications and robot applications. There also image processing plays a vital role, and simple definition and segmentation, all those things required. And weed. So if you want to regression, because we have to go for price forecast, so we have huge number of publications on this also. So for that, we have to go for regression analysis in machine learning. So here, how the regression models plays a vital role in agriculture sector. So here, quantity of rainfall is increasing. So let us assume sweet corn yields around 30 metric tons, but could increase by 2%. Whenever rainfall increasing, maybe it will let us assume increase the crop. then obviously, so we can look for such type of crop. Suppose it will decrease, then no need to look for such type of things. So that means crop prediction, if you want to do, so based on that, we can go for regression model. Or maybe farmers are paying, suppose rainfall is currently at 11 inches or maybe 11 centimeters. Will the farmers get a good yield this year? So based on the rainfall, whether farmers is going to get good crop. So for that, we have to go for regression. So we have historical data. Based on that, we'll try to predict. So if we are going to get good yield, then obviously we can go for that crop. If we are not getting good yield, we are going to lose, we are going to lose, then obviously no need to go for such type of crop. Because of that reason, so we have to go for regression models in agriculture. I will show some of the examples. So same thing, even Microsoft also developed some of the price forecasting model for farmers. Based on that, we can predict the price, and hence farmer can decide whether we have to go ahead with that crop or not. Or maybe we can go for prediction of the fertilizers or pesticides, etc. So maybe because it may vary the cost, fertilizers, pesticides, this cost will increase one day by day. Because of that reason, we have to look for such type of cost also, cost prediction. Then only we can go for, finally the farmer will get benefit, otherwise he is going to lose amount. That's why we have to go for prediction. So basically in regression, what it will do, let us assume, so this is the rain, x-axis is rain and crop yield is y-axis. Let us assume, try to understand it, very simple. X-axis is rain and crop yield is y. So these are all data points, data set. We have a data set, so that data points are here. Now what happens, let us assume, rain is 8.5 centimeters, the crop yield is 20, let us assume what we can call it as a, so tons, let us assume 20 metric tons. Now whenever rain is 11 centimeters, so how much metric tons we are going to generate? Suppose if the metric tons are increasing, obviously we can go for that crop. If the metric tons are decreasing, the crop yield is decreasing, then no need to go, because this year there is a possibility of 11 inches or maybe 11 centimeters rain, then we are going to get the less crop yield, then obviously no one will go ahead with that crop. Because of that reason, when you go for rain 11 centimeters or maybe inches here, they are assuming in the paper. So in that case, what happens? So obviously, so let us assume here, so somewhere we have to make a regression line, and obviously it will increase, crop yield will increase, obviously we can go for that crop. If we are getting less, then no need to go. Here you can see here, so we have to make a regression line, that is a linear regression model I am talking. So let us assume, so y equal to 2 plus 3x, so y equal to mx plus c or a plus bx. So we can call it as a mx plus c, that is a simple thing, mx plus c. M is nothing but slope and c is nothing but y intercept. This is c value, and slope, we know what is the meaning of slope. So whenever x value increases, how much y value increases, that is the slope. We can call it as a m equal to del y by del x. So this is nothing but slope formula. Suppose if I take 4 by 1, what is the meaning? Whenever one x value increasing, 1 unit x value increasing, y value will increase 4. Whenever 2 units increasing, y value increase 8 units. That is nothing but slope. That's why the formula is dy by dx. So the change of y depends on the change of x. Suppose if x equal to, let us assume y equal to, x is 1, y is 2, x is 2, y is 4, x is 3, y is 6. That means here slope is nothing but 2. So now what is the y-intercept c? Suppose if we take 2 plus 3x, 2 is nothing but y-intercept. So we have to start regression line here. This is the regression line. So now based on this regression line, substitute x value. We are looking for what is the crop yield at x equal to 11. So substitute x value, 2 plus 3x, 3 into 11. So that is the prediction of crop yield. So 33 plus 2, 35. So that means, which is very good. Then obviously we can go ahead with this crop, so that a farmer will get huge benefit. So that is the basic idea behind this regression line. So what we have to do, we have to construct a regression model, and after that we have to substitute the x value. Whenever the farmer getting better crop, then obviously he can go ahead with that respective crop. Otherwise he can stop, because he is going to get the loss. So but here y is nothing but dependent variable, x is nothing but independent variable. Always the value of y depends on value of x. When you substitute x value, then you will get corresponding y value. So c is y-intercept, m is nothing but slope, slope is nothing but del y by del x. So the variation of y depends on the value of it. So 4 by 1 means I explain what is the meaning also. So here, so regression models, connected crop yield and rainfall. Suppose if we take, let us assume rainfall is x value and y value is crop value. So when you substitute x value, what is y value? So we can identify the crop yield. So if the crop yield is less for the given rainfall, then no need to go for that crop. So that we can do easily by using this regression model. Just now I have explained briefly. And also, so strength of the relationship between two variables. If we have more than one independent variable, we can go for multiple regression. So here also same predicted yield if rainfall rises. So this type of things we can do by using regression model. So prediction using linear regression based models. So let us assume, I am assuming y is amount of crop harvested. So harvested means the gathering of the crop and at final stage, and x is nothing but amount of water. So let us assume, so I am assuming here x is nothing but amount of water and y is nothing but amount of crop harvested. So let us assume x, y. Amount of water is, let us assume what we can call it as a measure. So gallons. So 5,000 gallons I have. And what is y value? Amount of crop harvested, let us assume 10 metric tons. And here what we can call it as a amount of water 6, and here 12, and 7, let us assume 14. So like that, if you have a data, so x is nothing but water, amount of water, and this is nothing but harvested. So now we have to establish the relation between these two variables, y equal to m plus cx or a plus bx. We have to find the regression model, and based on the new x value, suppose x equal to 8, we have to find the y value. Based on that, we can go for further step. So same thing, what logic I explained in the previous slide, we have to look for regression model, and based on x value, I have water level very less, then obviously the crop yield is very less, then no need to go for this crop. So that's why we have to look for water and rainfall situation also. Based on that, we can predict whether we are going to get huge crop productivity or not. So suppose if we have more than one independent variable like x1, x2, x3, then we have to go for multiple regression. Here we can see here x1 one independent variable, x2 one independent variable, xn. I am taking generalization. This is generic. What I have explained in the previous slide, that is specific a plus bx. We have only one independent variable, one dependent variable. But when I'm talking about generic, we have n independent variable and obviously always one dependent variable. This is the outcome what we are looking, or we can call it as a final label or class. This is the class, or we can call it as a dependent variable. Rest are all independent variable. So this is the data set y, x1, x2. So what we are looking, suppose x1 value is given, this is the test data. First we have to train, after that we have to make a model. Suppose if we are looking for prediction of y, x1, x2, xn, we have to find the y value. What is the crop yield based on the n parameters here, or n attributes, and x1, x2, this is a test instance. So what is the y value, or what is the value of y corresponding to these input values or these independent variables. So this is applicable for generic. So when you have more than one independent variables, but what we discussed in the previous slide, so that is nothing but a specific one independent variable we have considered. Here you can see here harvest and water, that just now we discussed. So water level is x and harvest is y, and based on that we have to make a regression line to x plus 1. And whenever if we are looking for, so the client or user will apply 11 units of water, that is x equal to 11, predict the crop harvest. So what is the crop harvest, that we have to predict based on the x equal to 11. So now what we have to do, we have already calculated or we have evaluated the regression model. That means after training phase we got the regression model. Now we have to substitute the x value here. So this is the regression model we made based on the historical data after training phase. Now the test instance is x equal to 11, substitute x equal to 11. So 2 into 11 plus 1, so 23. So this is the harvest. So harvest is nothing but final crop gathering. So 23 is a, let us assume 23 metric tons, like that we can assume some measure. So finally better crop prediction, I mean productivity we are getting. So it's good to go for that crop. Otherwise we have to go for further step, or we have to look into other crop alternative. But here we can see here y, x1, x2. We are taking consideration of the parameters water level as well as sunlight. Sometimes we have to consider the weather condition also. That is also very, very important. So here I am taking sunlight. Whenever if I take water 5, sunlight 3, so harvest is 10. So for that, what we have to do here, y equal to a plus bx1 plus cx2. This is a multiple regression application. So we have two independent variables, water as well as sunlight. But previously what we have considered only water for the prediction of harvest, that is y value. But here sunlight also one of the parameter which may influence the harvest. So because harvest is nothing but here final crop gathering. So maybe 10 metric tons, because these words are little bit new to us, because in computer we don't have this type of terminologies, because in agriculture sector these are common. So harvest is nothing but final crop gathering, final yield, let us assume. Finally, what is the crop yield? 10 metric tons of 8 metric tons, like that you can assume. So here what we have to do, we have to go for multiple regression. So y equal to a, this is the slope, let us assume 3 plus b is a coefficient of x1, that is independent variable x1, let us assume. So 2x1, let us assume 5x2. So this is the regression model after training that data set. And whenever if we have a water level is 15 and sunlight is, let us assume 7, so we can find the harvest. So what is the y value? What is the crop yield? I mean final crop gathering. So that we can find. So y equal to substitute x1 value here, that is 7, x2 value 15, so that we'll get output, that is the final what we are looking dependent variable. So that means here, so we have either independent variable 1, we can go for linear regression. When you have independent variable more than 1, we can go for multiple regression. So this is a three-dimensional data. Three-dimensional data means, so three variables we have, two independent variables and one dependent variable. Suppose if we have n-1 independent variables and one dependent variable, we can call it as a n-dimensional data. So that is the number of columns, or we can call it as a number of attributes, that we can call it as n-dimensional data. So sometimes we have to reduce the dimension. So for that we have to go for principal component analysis, because sometimes some same attributes may be repeated or maybe similar kind of thing. In that case we can remove. So that type of things we can do in the pre-processing step. So that we can call it as a EDA, exploratory data analysis. So it will taken care of this type of dimension reduction. So for that we can go for principal component analysis. So based on that we can reduce the number of attributes or maybe number of parameters, so that we'll get less dimension and we can process easily, and it will take less time complexity also, and we can get the output as early as possible when compared to the more dimension. So this is one of the research article, so that is published by SCI Indexed Journal. Prediction of potato crop yielding using precision agriculture technique. So we have to go for prediction of potato crop yield. So by using that, we can go for machine learning. So this is the data set you can see here, NDVI, that is one column, ID, NDVI, yield. And what we have to do, we have to make a regression model here. And NDVI means normalized difference vegetation index. So these are all new terminologies to us. So no issue, just we can assume. So we have attributes, let us assume x1, x2 like that. So here we have to, yield is nothing but y, NDVI is nothing but x. So we have to apply linear regression, and based on that we can make a regression model. And whenever we have new NDVI value, we can find the yield, how much yield you will get, how much crop yield you will get, we can identify easily. So here we have to apply linear regression because we have one independent. ID no need to consider, it's not going to take into consideration. Just we can take x and y. Y is nothing but outcome, that is the yield value. So here you can see a dead plant or object. These are all NDVI values. Based on the NDVI values, very healthy planet means the value lies between 0.66 to 1. So and 0.33 to 0.66 means moderately healthy plant. Why we require this one means, so based on that NDVI value only we can look for yield. If NDVI value, let us assume lies like this, so 0 to 0. If the value is -1 to 0, then not possible to go for a proper plant in that soil because of NDVI value is very, very low. Such type of things we can take care into consideration when you go for prediction by using regression. So these are the limitations here. So 0 to 0.3 means unhealthy plant, and 0.621 means it's very healthy plant, and obviously we can go for plant and we will get the good yield also, or maybe good crop. Otherwise there is an issue and farmer going to lose. So for this type of applications we can go for one of the regression model, depends on the dimension of the data set, and hence we can go for further step. And here we can go for same data. So we have, this is NDVI data, and this is the crop yield. And we can observe here, whenever 0.5, 8.12 metric tons, and some data if we consider. Whenever if we have 0.6, 0.7, I have already told the value lies between 0.5 to 0.7. It's a healthy crop and you will get better yield. Otherwise, you won't get better yield. So suppose if you want to measure the evaluation measure, if you want to do for the regression, we can go for RMSE. This is one of the evaluation measure for regression. RMSE, root mean square error. So this is the predicted value, this is the actual value. What does it mean? So actually, let us assume, so x value, y value, and this is the y cap. This is the predicted one. So x is 1, y is 2, predicted value is 1.1. This is the data set, because training set also we have, testing data set also we have. If you want to evaluate the model, we can go for RMSE for regression. X is 2, y is 4. Let us assume here 3.9. X is 3, y is 5, y cap also 5. We have to find the RMSE value for the evaluation of the model. So suppose here y is nothing but actual value. In the formula you can see this is the actual value and predicted value is y cap. See the difference and whole square. So 2 minus 1.5 whole square, 4 minus 3.9 whole square, 5 minus 5 whole square, and make sum divided by number of data points, 3 here, and make square root, you will get RMSE value. Less RMSE value will give the regression model is more accurate or maybe best fit to the given data set. Higher RMSE value will give the regression model is not best fit to the data set. So what does it mean? So let us assume same data set, I have applied two regression model. One regression model, let us assume R1, maybe let us assume polynomial regression I applied, and here I apply linear regression. Let us I have applied one more regression, that is called ridge regression I have applied. So three types of regression models I have applied. I have calculated RMSE for these regressions models. Suppose here the regression model RMSE, this is RMSE. So root mean square. Why I am taking consideration of this one? Whenever if I go for any regression model, evaluation is very, very important. Without evaluation, we can't say this is the best fit to the given data set. That's why evaluation is one of the crucial step when you apply regression model. Based on that only we can say this is the best regression model or this is the best model to the given data set, and we can go for deployment. Otherwise we can't go for deployment. That's why we have to look for evaluation. So come back here, R1 RMSE value is, let us assume 0.04. I am assuming R2 RMSE value is 0.01. R3 RMS value is 0.6. Now we have calculated RMSE value for R1, R2, R3. Now when you are looking for RMSE value, so regression model 2, I'm trying to use some different color. This model yields the less RMSE value, hence this is the best fit. This is the best fit to the given data set, hence we can deploy to the application. So that means R1, R3 RMSE values are more when compared to the R2 regression model value. Because of that reason, the error is very less when you are applying R2 to the given data set, hence which is the best fit to the given data set. Hence when you go for deployment, that is the last phase of the machine learning. So once everything is done, training phase is done, testing phase is done, and evaluation phase is done, then based on the evaluation which model is the best fit, then we can deploy to the application. But in our case, R2 RMSE value is very low, hence we can go for deployment to the application. So that's why evaluation is very, very important. Here I have taken into consideration of only one evaluation measure, but we have MAE, we have MSE, like that, so many evaluation measures that we can consider. Based on that we can identify which is the best model for to the given data set. So when you come to here, we can make these are the plotting of the regression models, what we have discussed. And we have this type of crop recommendation assistancy. We have enter all the values finally. So best crop that you can grow is pomegranate. Like this will get output that I have shown already. We have some of the online tools. Based on that, we can find which crop is best that suitable to the soil, or what type of fertilizers we have to recommend to the soil or maybe crop. So this is one of the online tool for recommendation. Similarly here cotton, based on the information what I have provided, cotton is the best crop. And even irrigation system application also we can use AI. So because irrigation also comes under agriculture only, because without water what we can do with agriculture. So that's why whenever we go for irrigation system also artificial intelligence having application, like we can identify the irrigation leaks. Based on that we can go for further step, or we can go for diagnosis. So such type of things, we can go for monitoring system, surveillance camera, and it will monitor if something happens, some leaks are happening or some breaching is happening. In that case, we can go for immediate action. So for such type of applications also, we can use machine learning or deep learning models. And life cycle of agriculture, so preparation of the soil and sowing of seeds, adding fertilizers, irrigation, because irrigation also one of the part of agriculture life cycle, harvesting, wheat production, storage. You can see here each and every step of the life cycle we are using AI or ML application. That's why I have explained so many things. So you can see preparation of the soil, what type of fertilizers or what type of pesticides we require, it will recommend. Sowing of seeds, what type of seeds we required for based on the soil conditions, it will recommend. What type of fertilizers we have to add depends on the soil situation or weather conditions or crop. And irrigation, it will monitor or it will identify the holes, leaking holes, and it will monitor, it will go for further diagnosis. Weed protection, so we have weeding, it will remove weed automatically. Weeding is nothing but unwanted plant. Harvesting and storage also we can use AI. Like that, each and every life cycle, if you take agriculture field, we can apply artificial intelligence. That's why whatever I have explained, everything covered in the life cycle. That's why I am showing like life cycle at the end of the session. So that many use applications of AI applicable to the agriculture sector. So this is analyzing crop health by drones, because drones plays a very, very vital role when you come to the agriculture sector. There is a huge number of applications of drones. Nowadays, most of the places they are using drones. Even if you want to spying some fertilizers also, we are going to use drones and identify the health condition, all those things. And we have various types of drones: planting drone, irrigation drone, soil analyzing drone, health assessment drone, crop spraying drone, and crop monitoring drone. So everywhere we are using drones. Their imaging also very important, because imaging also incorporated in the drone system. Otherwise, if you are not taking image, how can you go for further step? So image processing also comes to the picture. It's an integration of so many domains here. So these many agricultural drones are available. Most of the developed countries, they are using these drones for a better crop yield. And this is one of the paper, crop yield prediction based on the machine learning, published in elsewhere. So here, same thing what I have explained. This is the input data and weather data source, and pesticides data source, chemical, and we have to make a data set after exploratory data analysis, pre-processing. We have to apply machine learning model, and we can go for yield prediction, crop yield prediction. So if the crop yield prediction is very nice or very good, then we can go for that crop. Otherwise, no need to go for that crop. That is published in elsewhere journal. And we can apply k-nearest algorithms also for a classification. That is not required now. And this is the data set. We have all the attributes like rainfall, pH value, humidity, temperature. Based on that, what type of crop we can recommend. So what I have explained in previous slides, how it will recommend based on the data set. These data sets are available. That is historical data. Based on that, what type of crop will recommend based on the input values. It may be pH value or humidity, whatever it may be, temperature, or maybe other parameters taken into consideration. Based on that, it will recommend rice is the suitable, or maybe ragi or potato crop is the suitable. Like that, it will recommend automatically. And computer vision also plays a vital role. So whenever if I go, it will identify. So which chicken is taking rest, which chicken is drinking water, this type of monitoring system. So we can go for computer vision. This is one type of surveillance camera. And automatic weeding, I already said, weed is nothing but unwanted plants in the agriculture crop. So such type of things we can remove by using automatic. We have some of the robot and or maybe automation we can do, we can remove. You can see here some of the unwanted plants here that we can remove. So now if you want to go for further enhancement, just I have shown all the basics, fundamentals. So many things I have incorporated: image processing, computer vision, machine learning, like that, agriculture and artificial intelligence. So many things are incorporated. If you want to go for in-depth, just I'm showing the basics. If you want to go for in-depth, I will show some of the resources. Based on that, you can go ahead with that. So here, artificial intelligence in agriculture. This textbook is CRC plus Taylor and Francis publishers. This is one of the standard textbook. Indian authors only you can understand. And artificial intelligence, this is the Springer publishers. There also we can find artificial intelligence not only for agriculture sector, you can find so many other applications also. But first one is exclusively for agriculture sector, and second is applicable for all the applications. Whatever I have shown in the first slide, what are the applications of artificial? We have huge number of artificial intelligence. That's why we can go for second textbook also. And if you want to go also looking any kind of research, we can refer this paper published in IEEE. So around 30 pages paper, this one. So machine learning applications for precision agriculture, a comprehensive review. We can find all type of algorithms or all type of applications of AI for agriculture. We can identify all those things in this paper. It's very good paper. That is authors also Indian authors only. We can identify easily, and we can find so many applications with references also. Based on that, we can go further enhancement of this machine learning applications for precision agriculture. So always when you are looking for more content, you try to go for review papers. There we can find so many things, and based on that we can go for further. Even you can find a recommended system in this paper also. So crop recommendation or fertilizers recommendation, all those things we can find in this paper. So that's my talk, how artificial intelligence plays a vital role, case studies, applications, and research directions. If you are looking for further enhancement, whatever I have shown some of the resources, of course, we have Google. We can go to Google and you can type, we can find still huge number of applications. Just what I have referred, that resources only I have shown. If you want to have these resources, I will share later to organizers and they will share to you, or I will share my mail ID. You can send mail, I will share these materials also. So that was my talk. So if you have any queries, I'm happy to answer. And some of the keywords not able to understand, I can understand, because these are all a new thing for us. These are all new terminology like weed, like pesticides and seasons, maybe Kharif, Rabi. These things are a little bit not that much old new terminologies, but you have to understand, no way to skip also. So if you have any queries, I'm happy to answer, or we can discuss anything related to the agriculture, how machine learning, deep learning, or image processing plays a vital role, so that we can do research also in that areas.
Thank you, sir. Dear participant, you have any queries, please ask, or you can enter the chat box.
Good evening, sir. This is
Yeah, good evening, madam. Vasanta, madam. Yeah, good evening, madam. Tell me, madam.
sir. Coming to weed detection, or it may be leaf disease detection. Whether we have
Yes,
to
madam.
apply
Yes, madam.
image processing techniques or deep learning techniques. Exactly where
Yeah.
which
Actually,
technique?
now, Actually, when nowadays, actually, most of them are using deep learning, because deep learning techniques are giving more accurate results when compared to image processing, madam. So, because when you go for deep learning, the data set should be huge. When you come to the image processing, let us assume if you have 5 images, 6 images, maybe you can go through with image processing. But if the data set is huge, like maybe 1,000 images, 2,000 images, deep learning is the most recommended for classification, madam. Suppose if you
Yes.
don't know, try to go for image processing also, fine, no issue. Because even deep learning is not that much easy also. Then we can go for image processing. We can go for image acquisition, pre-process image analysis, post-processing. You will go for segmentation finally. But we
So,
have huge number of papers on image processing for agriculture sector.
yes,
Yeah,
sir.
tell me,
At the
madam.
same time, we are finding deep learning techniques also. In that, we have a semantic segmentation. Is it a useful technique to apply for this leaf disease detection
Yeah.
and weeds
Yes,
detection?
ma'am. Yeah, semantic technique. Yeah. So especially for web applications, they are using the semantic technique, madam. If you want to go for any automation kind of thing, I have shown some of the recommendations automation. Just
Yes,
click
sir.
that one, enter details, you'll get output. So such type of applications, most of them are using this type of semantic segmentation, or maybe deep learning techniques, madam.
Yes, sir. Yes, sir. Thank you, sir.
Yeah, welcome. Thank you.
Any
So I
questions?
will post my mail ID also. If you have any queries, you can send mail also. I'm happy to answer. If I don't also, I will learn, I will explain, because I can't say
Thank you so much, sir.
no also. Yeah, welcome.
Thank you, madam. Thank you. Any questions? Any queries from participant? So if you don't have any questions, we're going to conclude the session.
Yeah, or you can type your questions in the chat box also, fine. So I will read and I will answer it. So, yeah, Naresh sir, thank you sir, informative session. Yeah, fine sir.
Okay, dear
No
participants, so if you don't
queries.
have any questions, we are going to conclude the session. Sir, thank you, sir.
We will give 1 more minute, sir, 1 or 2 minutes.
Okay, sir. Okay, sir.
Yeah, maybe if no queries, fine. Yeah, thank you, sir. Vasanta madam, thank you, madam.
Okay, sir, shall I conclude, sir?
Okay, fine, sir. Even I have to go for dinner. Now, still I'm in office only, college only.
Okay. So wonderful session, sir. So you are accepting our request. So we have given informative knowledge for participant. So I hope this session useful for the participants, sir. So we have given
Thanks.
wonderful concepts, different applications in of AI, importance of AI in agriculture, crop recommendations using AI, so importance of image processing, and how you're going to detect the weed detection. So you're also showing the different images, so the participant can easily understand, sir. So once again, thank you, sir. You are accepted.
Yeah, welcome, sir.
So for this, you are given. You're going to give small appreciation of token, sir. So accept our accept, sir.
Thank you.
Token of
Thank you, sir.
appreciation. So
Thank you for opportunity also, sir.
thank you, sir. Thank you. So thank you very much, participants, dear speaker. So we are going to conclude our session.
Yes, sir.
Okay. Thank you, sir. Thank you. Sir, please share the PPT, sir. So I can share the your participants, sir. Okay, na, sir?
Yes, sir. Yes, sir.
So,
Yeah, thank you all. Can I leave, sir?
yeah, you can leave, sir. So have a good night, dear
Okay.
participant.
Thank you, sir. Thank you all. Thank you all. Good night.